The Creative College is a project that will accommodate 1,500 students from the level of kindergarten to high school, located in Doha, Qatar. Doha is characterized by its desert climate and high solar incident radiation from April to November. In fact, it receives around more than 3,000 hours of sunlight per year. Understanding the challenge of designing a sustainable building that unified environmental, economic, and social aspects, we were inspired by the vernacular architecture of the region, which is characterized by cells grouping in a densely way with centrally located courtyards. Buildings constructed with mud as the main material that provides the necessary thermal mass in combination with naturally ventilated spaces through wind towers.
Qatar is one of the greatest energy consumers per capita in the world, with an annual estimated of 16 kilowatt hours per person. This is 3 times the UK average, so it's a major concern because the consumption has grown 7% during the last decade. Most of the energy consumption load in the city comes from air conditioning use, which became popular with the low energy prices.
Given the drastic climate conditions of the locality, it was imperative to develop a shading strategy for the reduction of both solar heat gains and unwanted glare during occupancy. So we incorporated re-soleil to avoid excessive direct sunlight in combination with PV panels to promote the use of renewable energy sources. Our target was also focused on maximizing natural light to lessen the use of artificial lighting.
In order to achieve good daylight lighting in the classrooms, the project was oriented north-south. As a consequence of the high solar incident radiation, we incorporated a fabric energy storage strategy, or thermal mass. Thus, internal thermal comfort can be maintained. EcoCrete is a part of the proposal as the main construction material. It will provide considerable thermal mass to the building by limiting solar and conduction heat gains. Following the idea of optimization, the project was designed in a modular basis, reducing waste, cost, and time. This is why we are proposing prefabricated elements, taking advantage of local companies that offer this option. In this way, pure in-place construction process is being replaced by an on-site dry assembly.
As a way of improving comfort, the building was buried 1 floor below the ground level. Thus, the soil will act as a natural insulator. As well, increasing the building height at south will provide more shaded areas in lower levels. The project was based in Doha's traditional architecture, where spaces are connected by shadowed corridors that provide natural ventilated and comfortable zones.
To achieve comfort temperatures, cooling towers were implemented. The towers work in a downdraft evaporative cooling which moisturizes the air, driving it downwards into the courtyards, removing the stale air. The wind towers have a safety feature that protects from dust and high wind speeds. Wind towers are common in the Gulf architecture. Projects such as Masdar City have implemented this strategy with positive results.